Okay, so we know that at GCSE, the half-life is the amount of time. The amount of time. So it's the amount of time it takes for a sample size to half. Okay, so if you had 1,000,000 atoms after one half-life, you'll have 500,000 atoms, and if you after a second half-life, you'll have 250,000 half. It's just going to keep halving. So at A level, you have a relationship between n, which is the number of atoms, is equal to the original number of atoms multiplied by E. I'm going to have to double check this formula, to the minus lambda t. I think I might have missed something there. We're just going to double check that. Okay, yeah, so I got that right actually. Now we also know that the activity, which we can call A, as in how much radiation is given off, is directly proportional to the amount of atoms that are there. So equating that, you can say that the activity of a sample is going to be equal to the original activity multiplied by e to the minus lambda t. So what is lambda then? Lambda is the decay constant. So at GCSE, you think about half-lives, and at A level, you think about decay constants. They're very relatable. What about E? E is a mathematical constant called Euler's number, and you have it on your calculator. I'm going to misspell this, right? Misspell this, I reckon, but I will double check that. I'm not sure if that second E should be an O. Let's just check. Oh, I'm doubting myself again. It's correct. That's the right spelling. So anyway, it's a mathematical number. We won't go into why, what's so special about it, but it is actually quite a special number. The point is, it relates. You get this number, and you do it to the power of lambda t. So let's see how the decay constant relates to half-life. Well, after one half-life, we know the sample size is going to half. So that means when t, the amount of time, is equal to the half-life, which we call t half, then n is going to be equal to half of the original sample size, so half of that. So we can rewrite the top equation. We could also do the same with this. We could say also that a would be equal to half of a naught, but this we'd end up getting the same answer anyway. So let's just do it with n for now. So we'll say, rather than writing n, I'm going to write half n0 is equal to n0 multiplied by e to the minus lambda, and t is t half. T half. And then we can see we can cancel out these n naughts. So let's do that. If you did it with the a naughts would cancel out. And we'll just simplify this, bring this closer together. Now you do something which you're going to learn about at A level. You do a log, and a log is a sort of mathematical tool which you don't have in your toolbox at GCSE. It's a way to rearrange an equation like this. So we want to, how do I get this? How do I rearrange it for having this on its own? What I have to do is actually, I think what I'll do, I'll just do log. So natural log on your calculator is ln. I won't go into teaching logs at the moment. So the natural log of ln is equal to negative lambda t half. And so now you can rearrange that equation by dividing both sides by t half, and also by minusing it. And you can see, therefore, that the lambda, the decay equation, is equal to is equal to minus natural log of half divided by the half-life. Okay.